Okay, now we're going to hear it from Jan. He's from the DFINITY Foundation, as I mentioned earlier. Jan is the CTO, and he also heads up the largest R&D operation in the industry. Jan, that is something quite big. We have a scientist in the room. He's also world-renowned, and he's specializing in the areas of privacy and cryptography. I believe, Jan, you also have 130 papers which have been cited. So you have a lot of knowledge, and I cannot wait for you to share that with us. So over to you, Jan.
Thank you very much. I'm very happy to be here today and talk to you about the internet computer, about Web3, and maybe why you want to build your next step on the internet computer. As Stacey was saying, I'm the CTO of the DFINITY Foundation. So our mission is to build the internet computer, which is like a novel blockchain that we've built from first principles from scratch. We do have a large team all over the world. We have some offices in Palo Alto, Zurich, but many people also work remotely. But yeah, let me talk about Web3 first, because I mean, there's some different views on what Web3 is. And Web3 is really the evolution of Web 1 and Web 2. And as you might remember, Web 1 was essentially the entrepreneurs were building applications, providing them, and users had a lot of fun surfing the internet and reading all that stuff. Then Web 2 came along with Wikipedia and so on, where actually the tools were developed where users could participate, they could contribute contents, they could moderate contents, they could adding value by adding their friends, like social networks and all of that kind of stuff. Users could suggest improvements, help develop an application, and even extend it using APIs. So for instance, like Facebook had this Farmville game that somebody else was actually building on top of Facebook, and that was largely successful. Unfortunately, then at some point, Facebook decided to change their APIs, and that company is called Senga, was essentially out of business. It would have like several billions in market or in capitalization, and then it overnight or over, I guess in the course of a week, it went down to just a few millions. But the point is that like Web 2 is where users actually make the app successful. But in some sense, I mean, that's just this example of Facebook, still the original builder benefits from all that value. I think Web3 is about to change that. So the idea here is that both entrepreneur and users are owners, and both of them are remunerated for their contributions. So the users get some get rewards, entrepreneurs get rewards, and it's a big happy family after all. So how can this possible? Actually, here's some examples of Web3 applications that already exist. And the examples here I am giving are essentially dapps that already are built on the internet computer. So for many Web 2 platforms, Medium, Reddit, Spotify, LinkedIn, Twitter, Gmail, there's already people building a Web3 version of that is hosted on the internet computer, that fully runs on the internet computer, and where now all of them plan to become Web3 in the sense that they can tokenize their dapps, can make users co-owners of all these applications. So I guess these are all like social web if you want, but there much more is of course possible. You can have DeFi on it, or even insurance, where like users come together, they pay some premium or some insurance rate, and then the money then gets redistributed, or people, if they have like a case of insurance, then they get paid that out. So I guess blockchain here also adds a lot of transparency to the overall process. Or another thing that is probably going to be very trendy will be a DAO for everything. So you just want to organize some little things, just by the click of a button, you create your own DAO and can organize your business. Right, but let me now dive into what sort of the requirements would be for such a Web3 application. So what kind of platform you need in order to build your Web3 dApp. Well, first of all, you want to have some form of tokenization being possible, because after all, you want to give some kind of token to users or also to the entrepreneurs for building that then, you know, is a share of your dApp or also has some value in the long run. So that means also the smart contracts on a blockchain can then also like move value just like other data. It also makes it much easier to build applications. Now, if you want to have like a dApp, an application run or controlled by users, if users should co-own an application, of course, you need to have some kind of DAO, some kind of anonymous, decentralized organization that then controls that application to start with. Now, these are more the functional properties that you want to have for such a platform. There's a few more like security properties. Of course, you want to have your platform secure, such that when you build an application, you don't have to worry about hackers. You don't have to worry about any kind of attacks. You don't want to be bothered with installing firewalls and all that kind of stuff. It should be simple and secure just out of the box. Once you have like an application, of course, you want it to be forever. In particular, if it's like a Web3 application that is owned by users alike, then you want it to be there. You don't want some third party going out of business, and then with them going out of business, the application just stalls and no longer is usable. Imagine if, for instance, like WhatsApp is certainly no longer available, then you sort of can no longer communicate with all your friends that you used to use WhatsApp to communicate for. Which brings me to the next point. You actually want the platform to be public, available, like the roads out there, right? So you rely on the roads for your daily commutes. And very much you want to also like a platform where you build your applications available very much as a public good. Last, but certainly not least, you want to have like a composable way to create your services, your dApps. And this composability is also already exists on the like Web 2, and a lot of the web services are actually composed from a ton of different services that then work together to offer the service that the users see at the end of the day. So it's just possible on a blockchain. When people think about blockchain, they typically have Ethereum in their mind, where costs are preventive and where transactions take a lot of time. And so you would think, no, I cannot build a full application on a blockchain. But actually, it is possible. I mean, maybe I've hinted towards that already by giving you a whole list of applications that are already running on the intercomputer blockchain. And here's a bit of an overview. And of course, I unfortunately have not enough time. I guess I could talk all day here to explain what the internet computer really is. But the internet computer is really a protocol that runs on top the internet on top of TCP/IP, and that protocol unified, or is a protocol that is spoken by a number of node machines in different data centers, and each of those node machines are like publicly owned, or is hardware owned by different parties. So anybody can buy such a piece of hardware and then submit a proposal to the internet computer and join the internet computer by just running the internet computer protocol. So currently there's 527 nodes that run this protocol, and together form 35 subnets that can host applications. So these subnets together work together to form the internet computer, which is really like a virtual computer that is distributed across all these different nodes. On top of the internet computer, we have like smart contracts. For the internet computer, we call them like canisters. And I will explain later a bit more what such a canister is. Currently, we have like 128,000 canisters, and we have seen an exponential growth in those canisters, which of course makes us all very happy to see how the ecosystem is flourishing. Now, yeah, what is a cancer smart contract? So it's essentially a bundle of memory pages and WebAssembly, in this case, like bytecode or the code. So that bundle we can then upload onto the internet computer, and then it just runs there. In some sense, you have that's sort of the building block for applications. So you can with many different kinds of smart contracts, you can build any kind of applications. So for instance, if you would have like a social network, which for instance, we have somebody was building, which called Open Chat, a chat network, like every user is represented by their own canister, and then the chat application that is implemented by these canisters talking to each other, making a chat application possible. And you might be astonished, and just go and try out for yourself. It's oc.app. Just can seemingly from your browser can log in there and check it out. So this concept of this kind of smart contracts also allows the blockchain to scale. Just add more canisters if there's more users. If you need more resources, you just add more nodes, and then all of that, the protocol can scale automatically. There's a lot of other properties here, but maybe for the reason of time, I'll just invite you to go to internetcomputer.org and learn more about those kinds of smart contracts. I guess what is important, you can really program them in any language. The most prominent languages currently used are Motoko, which is a language we have developed at DFINITY natively to make it easier to program a distributed system. But you might be more familiar with Rust, and so many canisters are actually also written in Rust. Another key property of the internet computer is actually that users can securely communicate with the internet computer directly. And that's like the only blockchain where it's really possible. So you can't just open up a browser on your mobile phone, type in a URL of a canister, and like a canister smart contract, and then that call is directly routed to the canister in a secure way. So this is enabled by two things. So on the one hand, I mean, if you want to have secure communication, of course, you require cryptography. So on both sides of on both ends, you want to have some public key that allows you to establish a secure connection. And on your mobile phone, it's like all the modern mobile phone have a security chip in it, and using web authentication via the browser, a session key is generated, and that can then be used to communicate with the internet computer. Now, the internet computer is a bit more tricky because actually it's a protocol, it's a network of many nodes. And here we have built a node protocol, the whole bundle of which we call chain key cryptography, but it's essentially generates a single public key of the overall internet computer that is then used to authenticate messages from the internet computer towards the user. So we have like the end-to-end secure connection with a blockchain. Again, that would not be possible with like other blockchains. So for instance, for Ethereum, if you want to authenticate, verify that the message is authentic, you would have to download like 300 gigabytes of data, because it's all like a big hash tree that you would have to verify for this. And for the internet computer, it's just a single cryptographic signature with a public key. So that's like one fundamental thing that is really necessary for building secure applications on a blockchain. So there's a ton of other properties that the internet computer provides that really enables you to build a dApp that is fully hosted on a blockchain. So first of all, based on the protocol I was just talking about, where users can directly connect to a Canister smart contract, the Canister smart contract can also serve web directly to the user's browser. So you can build a front end to your application fully on the blockchain, and then with the browser connect to that application. Moreover, a dApp, a smart contract on the blockchain, can also securely interact with traditional websites. So if you want to build some application that requires, let's say, exchange rates of tokens, of some other money, you can just make a call, your smart contract can make a call to the traditional service, just like call that URL, and then the Internet Computer Protocol will make sure that that call is made sufficiently many times by the different replicas. And then at the end of the day, that they agree that the answer to get back is indeed the answer that came from that website, and then serve that to the smart contract. Of course, the applications can be tokenized and can be governed by decentralized autonomous organizations. You actually really can build them in a way such that users can really truly own an application. So that means when you want to upgrade your application, when you want to change your code, those changes would be authorized by that DAO. And all of that is on the blockchain, so there's no like man in the middle that somehow could stop that from getting executed or actually fiddle around with the application otherwise. Probably the coolest thing for user is that actually as a user, you don't need to have any tokens. So you don't need to go to make some exchange, buy some ETH, and then with that ETH you can interact with a like an Ethereum smart contract. So that's not needed on the Internet Computer. Any user can just fire up their browser and connect there. And it's so the reverse gas model means that really the developer, the dApp, will have to pay for the users themselves. And of course, that means you would have to come up with some business model that founds the dApp. Most importantly, maybe the costs are cheap and stable. So as the developer, you know exactly what running a smart contract costs. It doesn't depend on the price of any token. So you know for years and years what the costs are in running your dApp. It's fast and it scales as well. So for instance, here just a few figures for comparison. If you would store like a mobile phone picture on the Internet Computer for 1 year, that would cost you like a little bit more than 1 cent. Given the current token prices for Solana and ETH, the same amount of storage right now would cost you like $500 on Solana or about $106,000 on Ethereum. It's also fast. The Internet Computer can sustain, with the current configuration, the more nodes we add, of course, the faster, the more capacity the Internet Computer has. So right now, if you write the data onto the Internet Computer, about 20,000 writes can be done per second. Reads are much faster because that can be read from just like any node, whereas for the writes, the nodes will have to agree, find consensus on those writes. And for reads, we can do more than 1 million per second already right now. Right. So okay. So how such a dApp look on a blockchain? So again, the idea is that all these smart contracts would be running on the blockchain. They would have different pieces. Some of them could be your backend data. Some of it could be your front end data. And those canvases together would then provide that service. And the backend data could also be like in the Facebook example, right? There could be some of it just would be the user data, the user profiles. And then like another service could come in and then actually build this farm wheel application on top of that. And they would have the guarantee that the backend data could not be changed because well, provided, of course, it's governed by their users, right? And the users really don't want to change those APIs. Which brings me to the next point. So also the whole governance of an application, of course, needs to be fully on-chain. So that means users would have access to tokens if they're given by the dApp, that also these tokens would live on the chain. Those tokens would then give the users voting right on the DAO that would govern that application. Now, of course, whenever the developers would want to upgrade their dApp, they would send a command to a DAO, say, okay, here's the next version, the next code. And then users could verify that code, could review it, and then decide, yes, we like those changes, let's upgrade the dApp, or decide, no, actually, we don't want to change those APIs because that would look at some other features. We don't want to upgrade that. So that really means if you want to build a Web3 application, all the parts end-to-end need to be run on the blockchain, because otherwise, if that's not the case, there will be always some party who could pull the plug, right? I mean, if you host something like on Amazon, there's always one party that would have to pay the bill to Amazon and host that contract. And of course, that party could just stop it. Indeed, stuff like that happens. And so here's like a typical architecture of almost all Web3 dApps that are not built on the internet computer. So here, well, you see when users want to communicate to such a dApp, they first would have to download some browser plugin from the web store. So like MetaMask is probably the most famous one here. And that is necessary so they're able to buy tokens from some exchange that then allow them to interact with their dApp. Now, the app itself is typically hosted on some cloud. I mean, this could be the web server, the dApp code, the database. So most often, all of that is hosted on clouds such like AWS. And only the interaction that involves tokens would really then be running on the blockchain. And even sometimes there, in order to interact with the blockchain, in this example here, maybe Ethereum, people rely on like single third parties to allow that access, because it's very hard to interact directly with Ethereum. So in the case of Ethereum, that most people actually use Infura to figure out whether some tokens have been transacted or not. You see that there's already a very complex architecture. There's many points of failures here. And you would say, well, as user, I don't care. I mean, as long as it works, I can install it. It's all fine. The problem is that really doesn't work, and there's like a lot of cases where this already has gone wrong. So, for instance, the Google Chrome store or Web Store did ban MetaMask already twice, and in both cases, of course, the users could no longer access their dApp. Another example is also that of course, the cloud could delete data. So for instance, Amazon also decided to ban Parler, which was like a social media service. Or BatchDAO got hacked, their Cloudflare account got hacked, and that ended up in like 130 million of users with their funds being lost. So I guess the point here is you really want to have like all the parts of an application fully on the blockchain, because then these things are no longer possible, because there's no single party in control. It can all be governed by a dApp. And in fact, the internet computer itself is also governed by a dApp, of course, right? I mean, so anybody who buys the Internet Computer Protocol token called ICP, they can stake that token and participate in the DAO that runs the Internet Computer or controls the Internet Computer and controls all the updates to it, all the changes to it. At the end of the day, owns the Internet Computer. So I'll invite you to join us and start building on the Internet Computer. There's a ton of documentation, sample dApps, and so on and so forth on the internetcomputer.org website. So please go there and have a look. And I'm also very happy to take questions in the remaining time. Thank you.
Thank you, Jan. That was absolutely brilliant and just a wealth of knowledge for us to learn about, and to the moon, math, crypto, and beyond. And also, I really thoroughly enjoyed your explanation going from Web 1 to Web 2 to Web 3. It's really nice to see that progression and just see it laid out like that. Again, just go over it. You guys are doing absolutely amazing things at DFINITY. The proof is there, and it's going to be so exciting to see what DFINITY has for the future. So thank you for your time. If there are any questions now for Jan or Matthew from the Delta, this would be your time to put it into the Q&A box. We encourage you, please, to engage with us and interact. If you feel like there's nothing to ask and you're ready for your dinner, that's fine too. You can always get hold of Jan. Jan, did you share your email address there on your last slide?
No, I did not, but Google is your friend here. You can easily search that. But it's Jan at DFINITY.org, so that's also easy to remember, I would assume.
Yes. Okay, great. Well, Michael from Soda World is just saying, great talk, thank you. So that's a great comment. Thank you, Michael. We appreciate it. We're here once a month. Okay, there's Salman Qureshi. He's saying, is blockchain hack-proof?
Well, it of course depends on the blockchain itself and how well it's designed, how well it's reviewed. But of course, the idea here is that you design a protocol, a cryptographic protocol, and then you do security proofs of the protocol to really make sure it is hack-proof. And I guess the reason with the current technical stack is that it did not really get built with security in mind, right? I mean, the internet was built like a long time ago to connect computers and make communication easy and reliable. It was meant to be proof against, you know, like atomic bombs and stuff like that, so they're very resilient, but they had no authentication, no encryption, and so on and so forth in there. And now what we have done at DFINITY for the internet computer, we really like started from scratch, building building cryptographic distributed protocols that clearly define how things go, and then analyze them, prove them secure, make even formal models and have formal security proofs, and then sort of build upon that. And now you have a protocol where nodes can compute to each other, and so those can communicate to each other, agree on what are the next steps to execute, and then you have like a sandboxed environment where these kinds of smart contracts can run. And then, of course, whether that code on top of it is secure or not, it depends on how you do that. But for sure, you cannot. I mean, whatever messages these smart contracts get, those will be the messages that are sent. And then when the smart contracts themselves are well built, and of course you could also verify them, then that's all you really need to take care about, right? Where in the traditional stack, you write your software, you take care about your software is secure, but then you also have to worry about all the rest of the stack. And that's if in a well-built blockchain, you would not have to worry about that, because that sort of comes built in because it is specifically designed for them.
Great, Jan. And we have another question. What volume of monetary commercial activity is taking place on the internet computer at the moment?
Yeah, that's a great question. Actually, we just had one of the social applications, Discover, announced their funding round. So they raised like a 9 million funding round just a few days ago. We had Origin, another DApp that actually last year even raised much more. I forget the figure, maybe it was like 20 million or something like that. So we see like a number of dapps that now are raising capital and start to develop out and getting bigger and bigger. We're also releasing like a way so you can like tokenize your dapps at the press of the button. So if you have like an application written, then you sort of propose to the network that you want to tokenize your things, and then also you can sell those tokens. We call it like decentralization sale, and raise funds like that as well. So you don't no longer have to be, I guess, in the Silicon Valley to connect to all those VCs, but rather with the help of the blockchain, you could even raise funds like that. Of course, that is like very early days here to change the model of how like an entrepreneur could raise funds, right? But I think that's also going to change the world, because you can just be somewhere in Siberia or in Africa, right? To build your dApp there, and then just submit a proposal, and everybody in the world will see, hey, there's this great dApp here, and then people can say, okay, I'm going to invest here, and you raise some funds like that already.
Great. I hope that answers your question, Nicholas. Over to Tobias. He would like to know, would ICP's blockchain architecture also be applicable for private blockchains used on B2B enterprise level?
I'm not sure whether I understand the question correctly. I'll try to answer it the way I understand, then Tobias, you can just iterate. I guess two things here. Like on one hand, of course, all the code is open source, so everybody in principle could just take the code and do their own blockchain. I'm not sure whether that would make sense in the sense that, you know, like if you have a protocol you just want to use it, you don't want to like worry about running it yourself. On the other hand, also, I mean, maybe you allude to the fact that many blockchains just have all their state public, and some blockchains have then use zero knowledge proofs to get some privacy. So on the intercomputer right now, we have sort of the sense of privacy that you would have to be a node provider in order to read the data. We use SCV encryption, so actually, even if you're not a node provider, it's not so easy to read that data. And we were having some plans to actually also add even encrypted computation, so that all the data is really encrypted. So even if you're a node provider, you could not read that data. But that's further down the roadmap. I mean, really, we have like a 20-year roadmap, and so, you know, we launched a year ago and have a ton of nice features already, but there's so much more to be built, and I guess we're all very excited about all that work that's coming up.
Thank you, Jan. And following on Nicholas's question earlier about the monetary value and commercial activity, David would like to know, you mentioned fundraising. What about commercial viability and profit generation?
Well, I think that depends on how you build your dApp, right? I mean, at the end of the day, if you have a great idea for an application, then that application or that great idea needs to also have some business plan how you would monetize that, right? It could be, you know, like WhatsApp becomes popular because everybody uses it, and then maybe you have some services within that require some fee. So for instance, the open chat application that already exists on the intercomputer, they allow you to transfer well, ICP, and we will integrate with Bitcoin soon, so you could also send Bitcoin as a chat application. And of course, then if you build that, you could take a small transaction fee and then sort of monetize like that. I think it really depends on the application, how you do it. You could also, I mean, even sell advertisement like the traditional internet model of financing things. But now with having tokens as well, right? I mean, I guess you have a better way to maybe put the monetization into the whole picture also.
Great, Jan. That's all our questions for this evening. So we wish you a wonderful evening in Zurich, and from us in South Africa, we say thank you again for your time. And just, yeah, that's as many questions as we've ever been asked after a session. So it's not often we have a scientist in the room, and we could probably pick your brain all night. So thank you for that, and we'll be in touch.
Thank you very much. And if people have great ideas, want to build, we also have a grant program, so to fund off some of those ideas. Please get in touch with our growth team, and then maybe we can even support you building something. Thank you very much. Have a nice evening.
Great. And that's what, you know, CBBC Africa is doing, is that we're collaborating with the best, and we're hearing it from the best, and just, it's just wonderful to have this platform to be able to speak. So until our next webinar, guys, we'll see you next time. Cheers.